Hello dear students, welcome to my YouTube channel. Today we are going to study periodic classification of elements. So in this lesson I am going to explain the important topics for your exam and the important questions that can come for your second semester. So let us start, dear students. So in this lesson we are going to study about the different laws like Dobereiner law, then Mendeleev's modern periodic law. Then we are going to study the different trends in properties of the periodic table. So let us start. First, what is the need of classification of elements? As you know, dear students, at present there are 118 elements. So from that only 94 are naturally occurring. So making order out of chores, these early attempts have been made at the classification of elements. Similarly, scientists have made several attempts to classify elements according to their properties and obtain an orderly arrangement. The earliest attempt to classify the elements was resultant in grouping them known elements as metals and non-metals. Okay, metals and non-metals. Later, further classifications were tried out as our knowledge of elements and their properties increased. So here you have to be very thorough with all the statements. So any one law can be asked in your exam for 2 marks. First we'll see about what is Dobereiner trait. So in 1817, Johann Wolfgang Dobereiner, he was a German chemist, and he has arranged the elements in such a way that similar properties into groups. He identified some groups having 3 elements each. Okay, and what he showed that when the 3 elements were arranged in the order of increasing atomic masses, you can see the elements are arranged in the increasing atomic masses. So middle element was roughly the average of the other 2 elements. So this, if you see phosphorus here, the middle element is the average of the other 2 elements. Okay. For example, see, you can take example of lithium, sodium and potassium with respective atomic masses 6.9, 23.0 and 39.0. So what will be the average of the atomic masses of lithium and potassium, and you can compare it with sodium. Okay, so you can see here some groups of 3 elements. They are arranged in the increasing atomic masses. Now here the system of classification into traits was not found to be useful. So next, Newland has discovered his own law of octave, that is known as law of octave. In 1866, John Newland, he was an English scientist, and he arranged the known elements in the order of increasing atomic masses. Note down, dear students. He found that every 8th element had properties similar to that of the first. Okay, so this is a law of octave. So in exam you have to write this statement. That is known as Newland's law of octave. So sodium is the 8th element. Yeah, if you see here, sodium is the 8th element after lithium. Similarly, beryllium and magnesium resembles each other. Okay, so that is you can see the Newland law of octave is given in this table. You can see the table here. This is Newland octave. He found that the law of octave was applicable only up to calcium. So this is applicable only up to calcium. Why? Because as after calcium, every 8th element did not possess properties similar to that of the first. So this is the drawback. You can mark down in your textbook. Again, it was assumed by Newland that only 56 elements existed in nature. So whatever the elements were there, that were only 56, and no more elements would be discovered in the future. But later on, several new elements were discovered, okay, so and whose properties did not fit into the law of octave. So this was one of his drawback. Yeah. Again, then with the discovery of noble gases, the law of octave became irrelevant. So this is another one drawback I've already marked here. Dear students, always you have to underline the important points in your textbook. You have to highlight the important points, important definitions, and while revising your lesson, it will be very helpful for you. So this was about the Newland law of octave. So every eighth element is similar to that of the first one. This was the concept of the Newland, okay, but it's having similar drawbacks, and drawbacks already I have explained, okay. Next, let us see Mendeleev's periodic table. So in the rejection of Newland's law of octave, many scientists continued their search, and then came Mendeleev's periodic table. So what is Mendeleev's periodic table? Let us see. So in Mendeleev's periodic table, the main credit for classifying elements goes to Mendeleev. He was a Russian chemist, and he was the most important, it was the most important contribution for the periodic classification of elements. So let us see the statements of Mendeleev's. The elements were arranged on the basis of their fundamental property. They were arranged on the basis of their fundamental property, okay, and the atomic masses, and also on the similarity of chemical properties. So when he started his work, almost 63 elements were known, and he examined the relationship between the atomic masses of the elements and their physical and chemical properties. So he selected hydrogen and oxygen as they are very reactive, and they form compounds with most elements. You can underline this. He also observed that most of the elements got a place in a periodic table and were arranged in the order of increasing atomic masses. So they were arranged in the increasing atomic masses. Again, the recurrence elements with similar physical and chemical properties, on the other hand, Mendeleev formulated a periodic law which states that the properties of elements are the periodic functions of the atomic masses. Note down, dear students, this is a statement of Mendeleev's periodic law. As I said you before, all the statements you have to be very thorough with all the statements of Mendeleev's periodic law. So in your final exam, they may ask you questions regarding Mendeleev drawbacks and achievements. So what was the achievement of Mendeleev's periodic law, or they may ask you about the drawbacks. So this is his periodic table. So achievements, as I already told, there are only few instances where Mendeleev had to place an element with a slightly greater atomic mass. You can see, dear students, here they are arranged, how these elements are arranged: first series, second series, first series, first series, second series. And if you see here, the sequence was inverted so that elements with similar properties could be grouped together. For example, if you see cobalt, which is having atomic mass 58.9, appeared before nickel, which is having atomic mass of 58.7. And Mendeleev has left some gaps. You can see here gaps. He has left some gaps. These gaps are left for the undiscovered elements at that time. Later on, Mendeleev named them by prefixing a Sanskrit numeral, that is Eka 1. Eka means 1, like whatever the preceding element is there in the same group. For instance, you can write as scandium, gallium and germanium, which were discovered later, which are having properties similar to Eka boron, Eka aluminium or Eka silicon respectively. So which was discovered later. You can see the atomic masses of Eka aluminum 68. This is the formula of oxide E2O3. This formula of chlorides ECl3. So This provided evidence of both the correctness and usefulness of Mendel's periodic table. Later on, the noble gases like helium, neon, and argon have been mentioned in many contexts before before this, and these gases were discovered very late because they are very inert, right? And inert, and they're present in extremely low concentrations in the atmosphere. You can see, don't have highlighted the important points over here. You can also highlight these points. So when these gases were discovered, like when inert gases were discovered, they could be placed in a new group without disturbing the existing orders. So these are all these achievements, and now let us see the limitations. So first limitation is electronic configuration of hydrogen resembles that of alkali metals, like alkali metals. Hydrogen combines with halogens, oxygen and sulfur to form compounds having similar formulae. On the other hand, you can see how there is no fixed position can be given to hydrogen in the periodic table. So this was the first limitation of Mendel's periodic table. Note down limitations, they'll ask in exam. For 2 marks at least you have to write 2 limitations. Isotopes, second limitation was isotopes of an element have similar properties but different atomic mass. Okay, so you know what are isotopes, and thus isotopes of all elements posed a challenge to Mendel's periodic table. And another problem was that the atomic masses do not increase in a regular manner from one element to the next. So it was not possible to predict like how many elements could be discovered between two elements. So he could not predict like how many elements he can discover between the two elements, right? Especially when we consider the heavier elements. So there was not a rough idea like how many elements can be discovered between the two elements. Okay, so these are the limitations of Mendel's periodic table. So note down, dear students, I've already highlighted the limitations. You can note down in your notebook or you can just mark in your textbook. That's all for today. In the next class, we'll study about the modern periodic table and the trends in the modern periodic table. Thank you, dear students. Please like, share and subscribe my channel, and do not forget to press on the bell icon. Thank you. Have a good day.